Hey everyone, and welcome back to The Explainer. Today we're diving into Class 10 Science Chapter 6, Life Processes, specifically Part 4. All right, let's get straight into this. If you tuned into our last session, you know we left things hanging just a bit. We tracked our food from the mouth, down the esophagus, and right into the stomach. But here's the thing. At that stage, the food is really only partially digested. It is nowhere near ready to actually give us the energy we desperately need. It's kind of just sitting there, waiting for the real magic to start. Which brings us to the big questions for today. Where does digestion actually finish up? Where do those nutrients finally cross over into our bloodstream? And what exactly are the liver, gallbladder, and pancreas doing behind the scenes? Look, these are absolutely crucial, highly tested concepts for your Class 10 board exams, and by the end of this explainer, we're going to have them completely locked down. Here's our agenda for today. 1. Journey into the intestine. 2. Liver and pancreas power. 3. The final chemical breakdown. 4. Absorption and assimilation. 5. The end of the line. And finally, number 6, a complete journey and review. Section 1. Journey into the intestine. All right, let's bring back the hero of our story, the food that's just about to leave your stomach. After tumbling around in all that stomach acid for, about 3 to 4 hours, your meal really doesn't look like a meal anymore. It's transformed into this thick, semi-liquid paste, and we call that chyme. Now, this chyme doesn't just suddenly flood out all at once. No, it slowly, carefully enters the small intestine through this tiny muscular valve called the pyloric sphincter. It's a very controlled entry into the next, and honestly, most crucial phase of this whole labyrinth. And once it's inside, it has a long way to go. Literally 6 to 7. The small intestine is this incredibly long, highly coiled tube measuring 6 to 7 meters in length. To put that in perspective, that's like the height of a 2-story building crammed right into your belly. Students always ask, why on earth is it so long? Well, it comes down to 2 things. It gives the body enough time to actually finish the complex digestion process, and it provides a massive surface area so the maximum amount of nutrients can efficiently enter your bloodstream. Now, to manage all that incredible length, the small intestine is divided into 3 distinct sections: the duodenum, the jejunum, and the ileum. And make no mistake, this highly coiled tube right here, it is the absolute main site of digestion. This is where the heavy lifting gets done. But the small intestine doesn't work alone. Section 2, liver and pancreas power. Let's meet the powerful allies making this whole thing possible. First up, the liver. This is actually the largest gland in the human body. Honestly, you can think of it as a massive biological factory. But for our story today, its main job is to produce a greenish-yellow fluid called bile juice. Now, think back to the stomach for a second. The food coming out of there is highly acidic, right? Well, the enzymes in the intestine literally can't survive in that acid. So, bile juice swoops in as the hero, neutralizing that acidic food, turning it alkaline, and creating the perfect, safe environment for the next steps. And that brings us to the second major superpower of bile, emulsification. Okay, I know it's a big, heavy vocabulary word, but the concept is super simple. Think about trying to melt a giant block of ice versus a handful of crushed ice. The crushed ice melts way faster, right? Because there's more surface area. Bile does the exact same thing to fats. It physically smashes large fat droplets into tiny, manageable droplets, increasing the surface area so fat digestion is much easier. Oh, and by the way, all this brilliant bile, it's stored and concentrated in a small sac just below the liver called the Gall Bladder, just waiting for the exact moment it's needed in the small intestine. Moving on to our next key ally, the pancreas. Honestly, you might want to grab a screenshot of this table because it is absolute gold for your exam prep. The pancreas secretes pancreatic juice into the small intestine, and it brings the specific chemical tools needed to dismantle our food. Look how specialized they are. Pancreatic amylase targets starch, breaking it down into simple sugars. Trypsin takes on the proteins, turning them into amino acids. And lipase tackles those freshly emulsified fats, breaking them down into fatty acids and glycerol. Section 3, the final chemical breakdown. All right, we've reached the climax of our digestive breakdown. This is happening right inside the walls of the small intestine itself. You see, the small intestine actually produces its own intestinal juice, packed with enzymes that execute the final, absolute completion of digestion. And here are the final, victorious results of that meal you ate. Those complex carbohydrates, they are now simple glucose. The heavy proteins, they've been completely dismantled into building blocks called amino acids. And the fats, reduced entirely to fatty acids and glycerol. These simple, elegant substances are finally ready to be used by the human body. Section 4. Absorption and Assimilation. So the food is broken down, but how do we actually use these nutrients? Well, this is the ultimate payoff for our body and a highly tested board topic. To get these nutrients out of the tube and into our blood, the small intestine uses an absolute genius structural design. The inner wall is lined with literally millions of tiny finger-like projections called villi. So why does this matter? Well, each of these microscopic fingers is packed with tiny blood capillaries. By folding into millions of these structures, the intestine creates a massively larger surface area. Without villi, we'd absorb almost zero nutrition. The villi guarantee faster, better, and more complete absorption straight into the bloodstream. Now pay close attention here, because this is a classic board exam trap. Understanding the exact difference between absorption and assimilation. Absorption is just the physical crossing over. It's simply the process where the digested food leaves the small intestine and enters the bloodstream. But assimilation? That's the action. It's what happens next. Assimilation is when those absorbed nutrients are actually carried by the blood to your cells and put to work, used to produce energy, fuel your growth, repair tissues, and form new cells. Of course, we don't always need to use all that energy at exactly the same time. It's kind of like saving money in a bank account. Your body brilliantly converts any excess glucose into a storage form called glycogen. It then deposits this glycogen into your liver and muscles. So later in the day, say you're playing sports or just haven't eaten in a while, the bank releases it, converting that glycogen right back into glucose to keep you running. Section 5. The end of the line. We're now entering the falling action of our journey. All the good stuff has been absorbed. So what happens to the leftovers? The remaining undigested material moves into the large intestine. Now, very little actual digestion happens here. The main job of the large intestine is essentially a cleanup and water recovery operation. It absorbs the remaining water and some minerals back into the body so we don't get dehydrated, and it forms whatever waste is left into solid feces. Finally, this waste moves into the rectum, which just acts as a temporary storage facility. And when the time is right, the body undergoes egestion, which is just the scientific term for the final removal of this undigested waste from the digestive tract through the anus. And with that, the physical, literal journey of the food through your body is officially complete. Section 6. Complete Journey and Review. All right, let's bring the energy back up for a quick review. We just built an incredible mental map of this whole process, so let's cement it. This is the absolute chronological path you need to have memorized for your exams. Ready? Food enters the mouth, travels down the esophagus, gets churned up in the stomach, undergoes major chemical breakdown in absorption in the small intestine, has its water recovered in the large intestine, and exits via the rectum and anus. Definitely lock this flowchart in your memory. Before we completely wrap up, I do want to address a very tricky student doubt that pops up in board exams all the time. Why is bile juice not called a digestive enzyme? Okay, the key here is that enzymes chemically break down food. Bile juice does not chemically digest anything. It acts purely physically. It neutralizes the acid and physically emulsifies, or crushes, large fat droplets into smaller ones. It sets the stage for the actual enzymes, but it isn't one itself. Super important distinction there. So we've seen how our food gets broken down into simple glucose and how it gets assimilated into our body's cells. But honestly, that leaves us with one massive vital mystery. Once that glucose is just sitting there inside your cells, how exactly does your body unlock and unleash the energy trapped inside it? Like, what is the actual spark that gives us energy? Well, think about that, because that is exactly the incredible process of cellular respiration that we're going to uncover in our next explainer. Until then, keep learning and keep asking questions.